Good evening to all. Is the audio and video clear for everyone? Please say. Thank you. So, in the previous session, we have discussed about the transportation problem and its degeneracy and the concept of maximization in the transportation problem. So, today we are going to start with the assignment problem. So, before going to start the problem, so please tell any doubts if you have over the previous session. So, the concept of assignment problem is very simple, that if you have m jobs and you have m persons, you are going to allocate one job to one person. So in a simple manner, we define assignment problem like this. So you have m jobs and m persons, or you can take n jobs and n persons. You are going to allocate one job to one person, so that the objective is nothing but minimizing the time, minimizing the cost, sometimes maximizing the profit, like this. So we can say that assignment problem is a special type of transportation problem. In transportation problem, usually what happens, you have a cost matrix. Here you have supply and demand. Then usually supply and demand are different, so that you have a procedure, and this is nothing but the cost matrix. In assignment problem, the supply and demand are equal. So you are allocating the cells with regard to the efficiency of the person. That is the main difference between the transportation problem and the assignment problem. Fine. So if you want a particular application of these things, so how to assign sales people to sales territories, that is one kind of example. How to assign different vehicles to different routes, that is one physical application. Another one, if you take, there are different managers and they are staying in a hotel and there are some rooms available for them. If they have given that this is my order of preference, so how to allocate the rooms to the persons, that is one type of thing. So if you have the contractors having different bids, so allocation of bids to the contractors, so all these things will come under the case of the assignment problem. So assignment, the very word signifies that you are assigning works to the people, so that the respective objective is achieved. Fine. Is that clear? So usually, if you think about the matrix order, it is always a square matrix, because you are dealing with n persons, n jobs. However, if the number of jobs or number of persons are in a mismatch, there you are going to introduce the dummy rows or dummy columns. Usually we introduce one dummy row or one dummy column, so that you will have a square matrix. And the procedure is very simple. So let us take one simple thing, that suppose I have 3 persons and 3 jobs. Let us say like this: person 1, person 2, person 3, job 1, job 2, job 3. I know that a person takes the job and what is the time, in how much time he is going to finish the job. So let us take that this is 10 minutes, 15 minutes, 20 minutes, 5 minutes, 6 minutes, 10 minutes, and 2, 3, 4 minutes. Now, what is my objective here? I have to minimize the time, the total time taken by the persons, such that one person will get one job. That is the objective. Clear? Is that fine? Yes or no? Right. So if you think in a general case that I fix for one person, I compare for the remaining two. So I am searching for different combinations available. So since we have a 3 by 3 matrix, how many choices you are going to get? If you fix the choices, only 5 choices you have, right? So it is a small case where you have very small number of choices. If you talk of 6 by 6 matrix, then how many choices you are going to get? Not 36. You are going to have the factorial. You are going to have the factorial. Because every time I am fixing one person and I can fix the others too. What is happening if you take the first case that I fix person 1 for job 1, I fix person 2 for job 2, and I am searching for person 3 among the 3 jobs which is suitable for 1. In this I am checking each and every possible case. So if you take 3, you have a 3 factorial, that is 6. If you take a 6 by 6 matrix, you will have 6 factorial. Because you are considering all possible choices. It is just like a permutation you can think of, right? So usually the regular simplex algorithm won't work here. So one simple algorithm is taken here to solve the problem, that is called Hungarian method. So the procedure is very simple. As and when you have a matrix, for each row you subtract the minimum value. I take the first row and I take the smallest value in that and subtract from that row. Again take the second row, subtract the minimum. So you do the same thing for all the rows. Similarly, take the first column, subtract the minimum value from it. So first we perform the row, then we perform the column usually. So after happening, you are going to allocate the values. So the advantage of assignment problem is usually if you have 5 by 5 matrix and you have got 5 allocations, means the solution which is given by you is nothing but optimal. So there is no further optimal solution check. If the number of allocations are not equivalent, then only we are going for a modification. There you'll get the optimal solution. So this is the whole procedure in solving a problem. Clear? Right? So let us take one sample problem. Then you have an idea. So this example I have taken that one 130, 175, 190, 200, 135, 120, 130, 160, 175, 140, 110, 155, 170, 185, then 50, 50, 80, 80 and 110, and then 55, 35, 70, 80, 105. So please take a note of that. So here 1, 2, 3, 4, 5 indicates the agency locations, and A, B, C, D, E indicates the cities. The values in the matrix are nothing but the distances from one place to the other. So the objective is we are going to minimize the distance. So how to allocate the values? That is the objective of the problem. Okay. Now, as and when the number of jobs A, B, C, D, E are nothing but the places, 1, 2, 3, 4, 5 are nothing but the agency places or agencies we can call. Right? So I am moving from one place to the another agency place, and the numbers here are nothing but the distances given. I am going to find the minimum distance there. Okay. So as I have mentioned, assignment problem is usually a case of transportation problem. So here the objective is also the minimization, usually, not the maximization. Right? Now, what is the smallest value in the first row? 130. So you are subtracting 130 from the first row. And for the second, what is the smallest? 120. You are going to subtract 120. So likewise, for each row, you are subtracting the smallest element in that. Okay. Is that clear? So this is called the reduction of rows. After performing the reduction of rows, you are going to take the columns one by one and check what is the smallest value in that column and subtract the value from that column. I think you are able to do that. There is no need to write separately on board, isn't it? Do you require? So, because our objective is the minimum, right? So we are taking the minimum among them. Actually, the concept behind the Hungarian method is, suppose if you have a matrix, since you know the row operations as well as column operations, you will obtain a new matrix. So if you add or delete a constant value from each row and clearly the each column, whatever the objective satisfied here, the same objective will be satisfied here. There is a theoretical proof under the Hungarian method. Since proofs are not in our criteria, we are simply discussing on the thing, the method only. Fine? Okay. So can I write the resultant matrix after subtracting the values? So if I subtract 130 here, it will be 30, 0, 45, 60, 40, 70, right? So can I write the values directly? Right. So we are going to get the values like this. I am performing subtracting the smallest value from each row. After that, I am subtracting the smallest value from each column also. Then I am writing the final result. Is that clear for everyone? Okay. So this is the thing you are going to get. 30, 0, 35, 30 and 15. Then you have 15, 0, 0, 10, 0. Then 30, 0, 35, 30. And then you have the value 20. Then 0, 0, 20, 0, 5. And in the last row, you have the values 20, 0, 25, 15, and then 15. So could you please check on that? So I want to take the inputs from everyone. Did you get the same matrix like this? Right. Now you are going to do the allocations. So if you take the first row, here 0 is given. So this indicates the smallest value, minimum. In other words, you can understand that if the place A and agency 2 are given, you can have the minimal distance that you can take into consideration. Fine. Are you getting the concept? So as and when you are making an allocation to particular thing, so you put a box around this. If you are making the allocation in a row, then where the allocation is marked, if any 0 is remained in that column, you cross that 0. Why we are crossing? Because our requirement is one person, one job, one place, one agency. So there should not be any allocation in that situation, because already agency 2 is allocated. So it will not be allocated to any other place. So the corresponding values are crossed here. Is it that clear? Yes or no? As and when you put a allocation in a row, the corresponding column zeros are crossed. Please understand. Again, I go for row 2. Please understand, in doing the allocation, first I check for the rows in which a single 0 is there. If there are 2 zeros, you can go for arbitrarily, but usually we go for a single 0 row check. So if we go for this, it was completed. Then if you go with the column, here 0 has there in the first column, I will mark it, and the corresponding zeros in the row will be crossed. Clear? How I am crossing the things? Any questions? I am making the allocations for the rows first, where a single 0 is there. You first check for the rows where a single 0 is there. Whenever you have a single 0 in the row, means there is no other option for the 2 to be paired, isn't it? And which gives the minimum. So if you understand that in the first row there is a single 0, so I am allocating place A to the agency 2. So it is marked. It means that agency 2 is paired with place A. So I cannot allocate the agency to any other place, isn't it? So I have crossed if any 0 is there in that column. So while I am checking with the rows, I am cancelling the zeros in the column. And I am checking for the single 0 things. Since I have 2 zeros here, I am not going for this thing. Again, I am checking for the rows, 3rd row, 4th row, 5th row, like this. Once the row check is complete, then I am going with the column check. So in the first column, I have a 0 here. So I have marked it, and the remaining zeros in the row gets cancelled. Again, there is nothing left for second column. If I go for third column, I will put a box here. The other zero in the row gets cancelled. Is it clear for all? Any questions, please? Now, what is the optimality check here? Because if you have the first zero means this is the first possibility and which is the minimum among the others. Let me say, if you have two zeros, then you can choose arbitrarily. So usually assignment problems will have multiple optimum solutions. Because if I have, this is the usual procedure generally we follow. Because if we feel that it is an echelon form, we are going from top to the bottom. As per the algorithm, it was described like that, not from bottom to top. Even though if you go like that, that's why I'm saying that you have the multiple optimum solutions. Because it is our decision that what a person can take, what type of job. We are just going for the allocation. That's it. It is our decision, practically, if you talk of. So, as and when you consider a matrix, usually rows means top to bottom, columns means left to right. So, we follow the same pattern here because we are assuming that it is a matrix. Okay. Now, how many allocations we have made here? 3. Actually, we have 5 by 5 matrix. So you must have 5 allocations, right? So the solution which you got here is not feasible. Now how to do to proceed next? Now in this matrix, we draw lines. Even though there is a procedure defined for drawing the lines, but that is not the issue. You can draw the lines either horizontally or vertically as per the choice, so that all the zeros must be covered. Right? So are you going to draw the lines so that all the zeros must be covered in that matrix? You can draw horizontally or vertically. That is up to your choice. Okay. Now I will say that I think everyone has noted this matrix. Could you note that? If you haven't, please take a note of that. If you didn't make a note, after noting, please inform. Right. Now see, drawing lines is our choice. So I am going to draw the lines, the minimum number of lines required to cover all the zeros. So on observation, or you can say on inspection, I can draw the lines like this. Did you accept that? Why C is there, you are asking? You can draw the minimum number of lines. Actually, since C has no allocation at all, usually we draw a line through that, where no allocation is made. Now, please check that if you draw a line through D, how many lines you will get to cross all the zeros? Here I got 4 lines, isn't it? To cover all the zeros. So if you draw a line through D, how many lines you will get to cover all the zeros? Right? So For this, can I draw like this? Then is this acceptable now? So if you draw the lines horizontally here, here and here, and you have one column left here, so 4 lines are required. Right. So what is the other way if you talk of to cover all the zeros? Can you draw 3 lines to cover all the zeros? So line through C is not required. Fine. Yes, we are taking the all zeros. That's why I have mentioned all zeros to be covered, including the allocations. So you can go for the lines on your case in drawing. Right? Now tell me how many lines you have required to draw the lines. I mean, to cover the zeros, including the allocated one. 3. Fine. So please give me the row values where to draw the lines. First of all, 2DB. That means column 2, D and B. Okay. Yeah. Is it clear now to all? All zeros are crossed. Right. So here one thing we need to understand that our inspection must be very particular, because if you are not care enough to draw the minimum number of lines required, if you draw an extra line, that will influence the solution. Fine. So here 3 lines are required to cover all the zeros. Now you have the remaining matrix, right? In the remaining matrix, what is the smallest value? So please tell me the smallest value in the remaining matrix. Is that 5 or 15? This is also crossed, right? This 5 is also crossed. I think the smallest value will be 15. Right. So this smallest value 15 will be subtracted from the uncovered values. So these are the uncovered values. From the uncovered values, you are subtracting the smallest value of the matrix. And while drawing the lines, you will have an intersection thing. So as and when you have an intersection, at the intersection values, you should add that value. That was the procedure. Okay. Are you getting the concept? What I have given? So if you subtract the values, it will become 15, 20, 0, then here 15, 20, 15, 5, it becomes 5, 10, 0, 0. At the intersection places you are adding them, so it will become 15 and it will become 15. Is this clear now? And I need to subtract the thing also here, it also becomes 15. Is that clear for everyone? Right. So if you have done the problem on your own, do you have the same values or different values? Please tell. Right. Now, again, we are going to allocate the things. So let me write the matrix clearly first. The values will come like this: 15, 0, 20, 15, 0. Then you have 15, 15, 0, 10, 0. And you have the other thing, 15, 0, 20, 15, 5. And you have the next row coming as 0, 15, 20, 0 and 5. Again, you have 5, 0, 10 and 0, 0. Is this correct? Please tell. Now we are going for the allocation. Since row 1 has 2 zeros, you can go for any allocation. So if I have taken an allocation at this position, then the corresponding zeros in the column gets cancelled. Accepted? So usually what happens, we always go for a check for the single zero. So if you go for a row check for all the single zeros, here you have a double zero, here double zero, here you have single zero. So first of all, we should go with this one. So the corresponding column zeros gets cancelled. Are you getting the thing? Now, once you have finished with rows, let us go with the column check. First column you have single zero. If any zero is there, you are going to cross it. Second column, there is no more zero left, allocation is done. In the third column, you have single zero and corresponding this one gets cancelled. And fourth, you have a single zero and this gets cancelled. And fifth, you have the allocation. Please check on that, how the allocation is made. So first we are checking for single zero rows. Then we check for single zero columns. That's it. Now, how many allocations were made here? 5. So the optimal solution is attained here. So how the allocation is done? So A is allocated to agency 5, B is allocated to agency 3, C is allocated to agency 2, D is allocated to agency 1, and E is allocated to agency 4. And how the values will be taken? The values will be taken from the actual matrix given in the problem. So if you go for the first table which is given there, for A and 5, the value is 200. For B and 3, the value is 130. For C and 2, the value is 110. For D and 1, the value is 50. And from E to 4, the value is 80. You can sum up all the values, which is nothing but the minimum value required. So the distance values which are taken from the original matrix, and we are taking the solution from the final matrix after doing the allocations required. Okay, is the procedure clear? So whatever the transportation problem is given, we follow the same thing. Even if the number of persons, number of jobs is a mismatch, then also we do the same thing by introducing a dummy row or dummy column. So let us imagine the case that you have the values here. This is the matrix I have got. Now what is to be done? What I have to go? I need to go for dummy row or dummy column. If the matrix is given like this, dummy column. So I will put zeros here. Now the problem has become a balanced assignment problem because we have obtained a square matrix by introducing the dummy row or dummy column as per the problem considered. So now you will do the same procedure. If you introduce a dummy column, there is no need to subtract the row minimum because for each row the minimum value is 0. So what we will do, we simply perform the subtraction from the columns itself. Then we go for the allocations. And the procedure what I have described now will be followed if the number of allocations are not equal to the required thing. That's all. This is the whole thing about the assignment problem. So compared to linear programming chapter, either simplex method, graphical method, transportation problem, the assignment problem is the most easy and convenient one. Yeah, I will take one more example. Can I? So I'm going to take a unbalanced one. Is that fine? Right. So you have 5 machines available for 5 jobs. Let us take like that. So I'm going to take the machines A, B, C, D, E and jobs 1, 2, 3, 4, 5. Whatever the case is, I am simply writing the problem with, just hold on a second, I will take a good problem for you, which gives the total. Yeah. So 62536 and then 25877. Then you have 78698. And 62345. Then 93897. And you have 47468. So let us forget about the headings, what they are. This is the matrix which I got with me. So you take that. These are nothing but operators. These are nothing but jobs. So 1, 2, 3, 4, 5, 6. I have 6 operators and I have the jobs J1, J2, J3, J4 and J5. And the values in the matrix are nothing but the time taken by an operator to perform a job. So those values in the matrix indicate that operator 1 takes 6 minutes to perform job 1, 2 minutes to perform job 2, like that. Okay. Now, is it a balanced assignment problem or not balanced assignment problem? Why? Because we have only 6% and 5 jobs, which is a mismatch. So what I have to introduce? A dummy row or dummy column? Dummy column. So I introduce a dummy job. The significance of dummy job is nothing but there is no job at all. So an operator will be on hold after achieving the solution. There will be no job allocated to one person. So among the 6 persons, 5 persons will be allocation of jobs, one person will be kept in the buffer. That is the concept of dummy row or dummy column, what you call of. So we take the values 0 here. That's it. Because they will take 0 minute because there is no job at all. Fine. Now you are going to perform the things. So first what we are going to do, you have to subtract the minimum value from all the rows. Since each row has 0 here, if you subtract 0 from everything, it won't get affected. So we are just performing only a column reduction. So from the first column, you need to subtract 2. From the second column, you need to subtract 2. Like that, you have to perform the thing. Okay. So can you go for this on your own? Yeah. So please go ahead. I will write a solution after the reduction takes place. Please check the table which you have written is correct or not after performing the column reduction. Yeah. Now, on the observation, you tell me how many lines are required to cover all the zeros. Because if you go for an allocation, obviously the solution is not feasible. You can say that. So straight away I'm asking that how many lines are required to cover all the zeros. The underlined idea is if you have a 6 by 6 matrix, if the solution is feasible, that means the optimal solution, obviously you require 6 lines to draw to cover all the zeros. That is basically happens. Because the optimal solution or the feasible solution, whatever you call, it must require the matrix order number of lines to cover all the zeros. As and when you have the number of lines is less than the order means it is not feasible, you are going to modify it. So everyone accepts that I need to draw 4 lines to cover all the zeros, right? So please give me the numbers so that I will draw the lines on board. Where I need to draw. You can give the job number or the operator number. So tell me how to draw the lines here. So job 1 and job D, right? J1, JD. So this is one line I have drawn. Then operator 1 and operator 4, right? Yeah. So that all zeros are covered, accepted to all. Right? J4. You are saying that J4. Right. So is this all zeros covered or not? See, the one typical thing is you can draw the lines as per your choice. That is also acceptable. The other person may have different drawing of lines so that all zeros will be covered. Here we are going to check how many minimum number of lines are required to cover all. So one J4 value. So one J4 value is nothing but 3. That is 3. Right. So do you accept with this solution, right? Yes or no? No? J4 column is wrong. So please give me the values under J4. 057274, is that wrong? So 046163, right? I'm going to write that 046163. Now this is acceptable. Right. Now, if the part is clear, since the allocation is nothing but 4 lines, you can go for only 4 allocations. So for the uncovered cells where the lines are not drawn, you take the minimum value. What is the minimum value there? For the rest of the matrix where lines are not drawn, 1. So from the uncovered cells, you are subtracting the 1, which is the smallest value. And understand one thing, that as and when you have the intersection, there you are going to add 1. So what happens at this position, here, here and here, I am adding 1. And for the remaining values, I am subtracting 1. So in this place and in these places, I am subtracting 1. Is that clear to all? Right? So can you do it on your own? Because it takes time to write the entire matrix. The problem with assignment problem. So should we draw lines before allocation? That is also acceptable, because once you get practice with the assignment problem, so even though if you have done the allocation, the same number of lines you will get. So the traditional approach is nothing but first performing the reduction, then go for allocation, then go for drawing lines. Now what happens on the practice, as when you got, on observing the reduction process itself, you can say how many number of lines are required to cover all the zeros. Whether you put an allocation or not, it is covered. Drawing lines is your choice. The only thing is, because the typical thing in assignment problem is nothing but drawing lines. Because assignment problem will have multiple optimal solutions. Usually unique solution will happen, otherwise always you get multiple optimal solutions. So one person will have the line pattern like this. At the same time, the other person may have different alignment pattern, but you have only 4 lines required to cover all the zeros. So what happens, whatever the allocation process you do, in the final solution will be same. The time, procedure or distance what you have got, that will be same. So we do the thing by applying our inspection there, how to draw and what to draw to cover all the lines. That's it. Okay. So once you subtract the smallest value 1 from the uncovered cells, and if you add 1 at these positions, you can get for the allocations. Right? So let us go for the allocations first. So if you go with the first row, since it has the multiple zeros, I am not going here. Again, you have multiple zeros. Since we have only one single zero here, I will go for an allocation and all the zeros will get crossed here. Right? So there is no single zero at all. There is no single zero at all. Now coming for the columns, we have allocation here. This also gets cancelled. Here, 2 zeros you won't get here. Again, you will go here. You will get a thing. Again, you will have single zero. This gets cancelled. That's it. Now what happens while drawing the lines? We apply the technique that as and when there is allocation is made, usually a line passes through the allocation to cover the zeros. That was the thing. Usually a line passes through the allocation so that all values will get covered. Okay. If you want a theoretical approach, is there any specific procedure to draw the lines? I will give a picture in the Telegram. You observe that, but usually you will get confusion over the procedure what they have described there. Okay. But in general, we go with our inspection technique. So at the end of the class, I will give a picture for you. In the Telegram, you can check that. How to draw the lines. So you are stuck with how to draw the lines there, right? The only problem with you, right? So if you want a procedure, first we mark the rows where no assignment is done. Mark columns two, then if so this is one strategy which we usually follow. Okay. So right. So at the end, I will give a strategy for you, the theoretical procedure, but usually which we won't follow because assignment problems will have the multiple solutions. So what happens? We just check for how many minimum number of lines are required to cover all the zeros. That's the thing. Right. So I think you have done with the previous problem. Have you performed that thing? So I think, would you get the answer as 16 or 17? The final value? So can I say that operator 1 gets job 4? Is that right in doing the allocation? Right. So operator 2 gets job 2, say job 1. Am I correct? And operator 3 gets the dummy job. job dummy. Operator 4 gets the job 5. Operator 5 gets the job 2. And operator 6 gets job 3. Is that right in the allocation made? So since we don't get the consideration of the dummy, so we take the respective values 1 J4, 2 J1, 4 J5, 5 J2 and 6 J3. Summing up the values, the thing which you have mentioned will be correct. That will be 17. So what about the others? Do you have the same thing here? 17 or 16? Which one you got? The values must be taken from the original matrix. Please tell. Right. So I want to mention one thing, that usually if you have followed any standard textbook for these transportation and assignment problems, so with respect to assignment problems, usually always the textbook is correct because they will be taken care in printing the correct solutions and correct values. Sometimes you will get the printing mistakes in the books that you should take care of. So while deciding the problem nature, you have to do it on your own, then only go with the answer part. That is my suggestion to you. Because the problem with yes and no problems is usually you will get a 7 by 7, 6 by 6 or 8 by 8 matrix. This is the typicality in the examination point of view for the assignment problem. So now what happens, since while printing takes care of either performing the row reduction or column reduction, you will have a chance of getting misprinted number there. So you please ensure that you have performed the thing on your own and come to the final solution. Okay, is that clear? So I think everyone has done with the problem of assignment. The procedure is very simple, just subtracting the value, drawing lines and doing the allocation. Now if you think of what is left for the assignment problem, there are only two things in the assignment problem. One is the maximization case. Another one is you will get a matrix where some cells are not allocated with anything. These are the only two things left in an assignment problem. So one thing is the maximization case. Another one is you will get some cells where no allocation is done. Because assignment problem is very simple to follow in the procedure. So I will give the description for the maximization case, and I will take a problem on which there is no allocation is done. Okay. Are you getting the concept? Yes or no? Any queries for anyone, please? Fine. So let us go with the maximization case. Just hold on a second, I will take a problem on this. So I have 5 different machines and 5 different jobs, and I will give the corresponding profit matrix. And my objective is to maximize the profit. So here the matrix goes. the values are taken by 30, 37, 40, 28, 40. And the second row consists of 40, 24, 27, 40, 24, 27, 21, 36. Then you have 40, 32, 33. And 30, 35. Then for the fourth row, 25, 38, 40, 36, 36. And the fifth row having 29, 62, 41, 34, 39. Please note down this. After noting, you please inform. So in this, our objective is nothing but to maximize profit. Earlier, whatever the matrix you have written, the values in the matrix are nothing but distances, cost values, etc., or amount of expenditure as specified per the problem. So here in this problem, if you take, so I can say you can call it as the job and you can take them as the machines. So what happens if I perform job 1 on mission A, I will get 30 rupees as profit. If I perform job 1 on mission B, I will get 37 rupees as profit, like that. That was the case. You need to understand like that. So my objective is I have to maximize the profit. So as and when you take the transportation problem or assignment problem, the algorithm is designed for to find the minimum value, not of the maximum value. The algorithm is designed in such a way. So what happens? We are converting this profit matrix into relevant cost matrix. So how to that? You can pick up the maximum value in this table and subtract each and every element from the maximum value. So you will get the relevant cost matrix. So we apply the same procedure, doing row reduction, column reduction, doing allocations, drawing lines, everything is common. Then you will have the minimized cost so that you will have the maximized profit. That was the whole idea, right? So what is the maximum value in this matrix table? If you observe the cells, what is the maximum value? 62. So you are subtracting each and every entry in this matrix from 62. So you will get 0 here, the remaining will be taken care place. So can you do that on your own? I will read the result. Right. So I am going to erase this. So you are going to result. You please perform on that on your own. So 34, 22. Then you have 22, 38, 35. And then 41, 26. Later you have so you please check on this table. If everyone agrees with the entry values, then I proceed further. And please understand that solving the problem is as usual. For each row, take the minimum value. In the first row, the minimum value is nothing but 22. You subtract 22 from the first row and so on. And after performing row reduction, you simply perform the column reduction. From each column, take the smallest value and subtract the other things, right? So then we are going to do the allocations. Clear to all? I think, can I write the solution from that part straight away? Okay. So do you accept with this part? So please check on the procedure. So let us wait for the others too, whether they have achieved the same thing or not. So what about the others? Do you have the same result? So if you go for the allocations, where the single zero is there, you can have one allocation here, the corresponding zero gets cancelled. Again, you can go for an allocation here, right? So since you got 4 allocations, you can say that the minimum number of lines required are nothing but 4. So that is one kind of understanding that how many lines we need to require is nothing but 4 lines to cover all these things, say, or 5 lines you are going to draw. Now, right, so please tell the numbers, I will draw the lines again. A145, A145, right? So I was talking about column A, row 1, row 4, row 5. Is that right? So this is A. I will go for first. I will go for row 4. I will go for row 5. So that all zeros are covered. Yeah. Now, if you check for the uncovered elements, what are there? What is the smallest value there in that? 4. So 4 will be subtracted from all the uncovered elements, and the same 4 value will be added wherever you have an intersection, here, here, and here. Is that acceptable now to all? So can you perform that on your own? Right? Then I will write the resultant one. So please check this final matrix. Yeah. The final solution is nothing but 214. I agree with you. So if you go for the allocations, so as and when you have a single zero, we should cross the corresponding things. You have a single zero here, we should allocate that. Coming to the columns, you have a single zero here, this row gets cancelled. You have a single zero here, this gets cancelled, and you have a single zero here. Is this allocation right? Right? So how the allocation is done? Let me write here so that you have an understanding. Job value, machine value, profit. So if you take the first job, it is allocated to C. Profit you can take from the original matrix. If you take the second job, it is allocated to mission E. If you take third job, it is allocated to mission A. Fourth job is allocated to mission C, and fifth job is allocated to mission B. Corresponding profit values you take from the original matrix which is given in the problem, where you didn't subtract any element earlier. The first matrix in the problem we need to take, right? So if you take the values, one C value is nothing but 40. Then you have the next value 36. The next profit value is 40. Then you have 36 and you have the 62. So that the total value is nothing but 214. So in this way, we perform the assignment problem. So if you compare with the weightage of assignment problem, as and when you have a 7 by 7 or 6 by 6, the usual weightage will be 15 marks. Because the only thing is nothing but you need to perform good number of additions and subtractions there. That's it. Because there is no typical procedure except drawing lines and doing subtractions in the whole table. I think it is clear for everyone. So the only concept left in assignment problem is, if some cells are not filled, they are with gaps, how to do such type of assignment problems. So I am going to take a session on Saturday itself, and the doubts whatever you have posed, I am going to address the same thing on the day itself, on Saturday. So tomorrow I am going to take an introductory class with real analysis, and I am planning to take the usual sessions from Monday onwards for real analysis. I hope it will clarify all your doubts. So whatever the part you have a doubt with that, you please post the question in Telegram. I will give the relevant or appropriate material for that, which clarifies your doubts. So any more questions, please? So one thing is evident, that among all the methods which you have learned so far, assignment problem is very easy to solve. Just doing subtractions and drawing lines. Is that accepted to all? So let us wind up our session here. So apart from this thing, if you have any other queries, you can ask. I will plan accordingly. In VAM, if values degenerate, why to find solution? Please understand, as and when you frame a problem, it is an objective. In any way, you need to find a solution there for it. So if it is infeasible, there we can say that no solution exists and you cannot find the minimum transportation cost. If you are able to find at least one feasible solution, you can say it has the feasibility. Maybe it is not possible to find an optimal thing, isn't it? Because as and when you frame a problem, you should have a solution. Otherwise, the very purpose of framing problem is wrong. So if you have gone through that solution where you have introduced two epsilons, now tell me, what is the thing there, the final conclusion given in that problem? Because we have seen that material already. So did he resolve the degeneracy there? By introducing the values? Right? So is that degeneracy resolved there? The thing is, if you talk of generally, in a closed path, if two cost values are equivalent, then degeneracy happens, two cells will be removed. So what happened? That value will be allocated to the closed path. So again, if you are calculating the optimal solution, Ui and Vj, there what happens? In that thing, you will have two positive things. So those two positive things simultaneously will be eliminated in this degeneracy procedure. That we can understand. So that you will have the chance of getting optimal solution. Because we are allocating the epsilon in the closed path itself, not in a distant place. So different books will give different notations. Maybe it is sufficiently large or to indicate the difference there. So M generally indicates the Hughes value. So let me go through the problem, then I will give the full clarity over that. Right. In assignment problem also, you will find such problems with given M. So what happens in the assignment problem, as and when a cost cell is indicated, sure, as and when a cost cell is indicated, so if the cost is very huge, then what happens? We put infinity, or we will leave blank, or we will get a symbol M. M indicates sufficiently large. That is the idea there. Okay. However, I will take care of that problem in Saturday itself, or I will post the detailed solution in Telegram, whichever is the case. So any queries from any other one? Right. So then that's all for today. We will meet on tomorrow with real analysis introduction concept.